antigravity, a force yet to be recognized by physics. There are numerous observations for which conventional principles of physics do not give good explanations. For example, consider a boiling kettle of water. Steam coming from the spout is invisible, but as it condenses, droplets become visible. We see condensed water droplets rising. Even if the spout of the kettle is inverted, the condensed water droplets will rise. To further check this phenomenon, a laboratory experiment was conducted. Steam comes out of the tube in the downward direction. Steam is actually invisible. What is visible is condensed steam. Condensed water droplets spouted downwards would quickly turn and move upwards. What caused them to do so? Infrared images of the condensed droplet path shows that condensed droplets exiting the spout and moving down encounters a negative temperature gradient. Therefore, convection currents cannot exist. What caused condensed droplets turn and move upwards? Imagine a condensate water droplet in still air. Condensed water droplet is about 1,000 denser than air. Buoyancy cannot cause this phenomenon either. All possible causes of upward movement that conventional principles of physics suggest do not happen here. The known causes for upward movement of water droplet in still air, convection currents, buoyancy, do not explain the above observation. The motion of heated water droplets against the direction of gravitational pull. Therefore, the above systematically observed phenomena is further experimented in controlled laboratory environment using iodine particles in vacuum. 1 by 10^5 MBAR. An experiment was designed to observe iodine particle behavior when heated in a vacuum chamber. Vacuum chamber was selected to eliminate all factors that are believed to be causing the upward movement of particles against the gravitational pull in air, viz., buoyancy and lift force due to convection currents. Iodine was selected because it is 9 times heavier than air and has a distinct color that enables easy identification of the location where it deposits. This is the experimental setup. Vacuum chamber, vacuum pump, electrically heated plate, iodine crystals deposited under the heater plate, deposited underneath to inhibit directly upward movement. White color circular paper jacket placed to capture iodine deposits. When heating is not applied, at room temperature, iodine particles leaving the iodine crystal deposit move downwards and deposit at the bottom of the paper jacket with time. Such deposition can be visually observed. When heating is applied, iodine particles leaving the iodine crystal deposit move upwards and deposit at the top of the paper jacket with time. Such deposition can be visually observed, as the heater plate itself covers the iodine particles from moving directly in the upward direction. The particles initially move down, turn around to move upwards to deposit at the top of the paper jacket. At room temperature, iodine particles move down under gravity, as expected. When heated, iodine particles move up against gravity. When temperature increases, there is a force acting against gravity. What I explained is just one experiment. There are 4 other experiments that vindicated the existence of a force that acts against the gravity with increasing intensity at higher temperatures.
As experiments yielded that gravitational forces on matter are twofold. Gravitational attraction force proportionate to mass, as known classically. Gravitational repulsion force proportionate to thermal energy, as deduced from our experiments. Our calculations using experimental data yielded that, compared to the classically known gravitational force, orders of magnitude of both the attraction and repulsion forces are extremely large. Classically known gravitational force, which is identified as the weakest of the 4 fundamental forces, is actually the resultant of 2 extremely large forces. It has been known that gravitational attraction force is proportional to the mass. Further research in this program has revealed that gravitational repulsion force is proportional to the thermal energy. When thermal energy is high, repulsion force is greater than attraction force. Resultant is in the upward direction. Example, condensed steam droplets going up like you saw in the video. When thermal energy is low, repulsion force is smaller than attraction force. Resultant is in the downward direction. Example, objects falling to the earth. Anti-gravity is a force to be recognized by physics.